Okay, this is the review for Algebra 1 for our test on Chapter 7. So I know it's not focused at the moment. I'll fix that very soon. So we're starting on page 481, doing varied problems here. We'll get to the other pages hopefully in time. I know you may not see all these numbers, but it'll be on the post, and it's mostly just so I make sure I do all the correct ones. Okay. Very good. So I'm on page 41. I'm going to start with number 1. It says x squared times 7x to the 8th. So you do want to multiply the coefficients together. Remember, there's an understood 1 coefficient in front of this and a 7 here. Treat coefficients like normal. There's not weird rules about the coefficients. It's the same thing you do on all year. 1 times 7 is 7. Now, the exponents are what's new and what's different from before. We're multiplying x squared times x to the 8th. When we're multiplying two different pieces that have exponents together, we have to add them. So it'll be x, and we do 2 plus 8, so that's 7x to the 10th. Because we have to add the 2 and the 8 together, so we get 7x to the 10th. So 2 is a more complicated version of this for sure, but it's still the same process. We'll just have to break it down for each individual piece. Okay. So this is number 2. We start with the coefficients, and as I said, we just treat the coefficients like normal. 5 times negative 6 is negative 30. That simple. A to the 7th times a squared. Since we're multiplying two different things together, we add the exponents. 7 plus 2 is 9. Now there's an understood first or 1 exponent there and there for the b's. So b to the first times b to the first is b squared, because 1 plus 1 is 2. Then we do the c's. C squared times c to the 5th. We add 2 plus 5 and get c to the 7th. Okay, now we're jumping down to number 4. So on number 4, we're simplifying things that have a start in fraction form. Now we can only simplify when they have the same base. In other words, we can do something to simplify the x's, but there's nothing to do with the y except just leave it as it is, because there's no other y that we can use to simplify that y with. But just as we talked about in 1 and 2, when we're multiplying, we add the exponents together. When we're dividing, we subtract the exponents. So for the x's, we have x to the 6th divided by x squared. So we subtract 6 minus 2, and that becomes x to the 4th. And then this is the only y around, so there's nothing else to simplify it with, so we just write it just as it is. And there's no denominator anymore. It's not a fraction, because we already simplified these, and the piece we have goes on top, because the bigger piece, x to the 6th, stays on top. So this is essentially canceled out. We just have 1 on the bottom, so no reason to write that as a fraction. Okay, number 5. It's as simple as it can be. It's an issue of memory. Because honestly, when you first look at this one, you're like, oh my gosh, this looks terrible. I would agree. Looks pretty monstrous. But then, you see the exponent. That's the best exponent there is, because anything raised to the 0 power is equal to 1. So you have to do no work on this. You just have to remember, anything raised to the 0 power equals 1. Okay, number 6. 2xy to the negative 7th over 8x. So again, treat the coefficients, that's the 2 and the 8 I'm talking about, just like normal, just like a fraction, 2 over 8. Well, we can reduce 2 over 8 to 1 over 4. And you don't have to write the 1 if you don't want to, but you can. So we took care of the coefficients. Next, we'll take care of the x's. Well, x divided by x is equal to 1, and we already have that 1 covered right there. So they just cancel each other out. You can also think about it like subtracting. It's x to the first divided by x to the first. So we subtract 1 minus 1 and get 0. But as we just said in number 5, anything raised to 0 power equals 1. So x to the 0, if that's what you want to say we got, would just equal 1. So the x disappears. We do not want negative exponents. We do not want negative exponents. The way we fix that is we change what part of the fraction that's in. So since y is currently on top and has a negative exponent, we can move it to the bottom and give it a positive exponent. Okay, number 7. I'll switch over. I don't have a calculator handy. Let's see. I'll just tell you how to plug each of these in. So in your calculators, you would click 3. Let me write the question first. Cube root of 1,000. Let me see if I can quickly pull up. Sorry, give me just a second. Let me see if I can quickly pull up the picture of y'all's calculator. I can remember what it's called. That's close. Okay, I think this will do. Perfect. Okay. So what you would do on this is you would first press a 3, because the question is the cube root of 1,000. So the way you do a cube root is you type the number 3 first. Then to do a cube root, we have to use this right here. So to get that, you have to click the second button and then this caret button. So second is what makes it do what's on top instead of what's on the button. So again, you would type the number 3, you would hit second, and then this root, and then you type in 1,000. And it turns out the cube root of 1,000 is equal to, is equal to 10. But this is just a matter of plugging in your calculator, so don't overcomplicate it. 9. In your calculator, you'd want to do 1728, and then do the caret for the exponent. And you must put parentheses around all fractions you put in there. And to get that fraction, you can just use the divided by symbol. So you type in 1728, the caret button, and then put parentheses and say 1 divided by 3. And that will turn out to be 12. Okay, 11 is 27 to the 2/3. That's the question. So in your calculator, you type in 27, the caret, parentheses 2 divided by 3. And that will be equal to 9. Okay, I'll do 13 over here. 13, the question says 27 to the 5/3. So we would type in the calculator 27, then the caret, parenthesis 5 divided by 3. So anytime you have a fraction, just use the division sign as a way to make the slash, and make sure you put that fraction in parentheses. Okay, 15, a little more work. So 15 is 12 to the x equals 1728. So we've got to figure out if there's a power of 12 that's equal to 1728. So my calculator won't look exactly like yours, but I can still use one for us to kind of guess and check here. So we're trying to say what power of 12 will give me 1728. I think I can make this. Oh, okay, it already is. So I could say 12 raised, I'll use this button here, let's say to the 3rd power. Oh, perfect. So 12 cubed is 1728. So this one will actually go very quickly. So 12 to the x equals 12 cubed. Because again, what we just found out is if we do 12 cubed, it's equal to 1728. And anytime your bases are the same, your exponents also have to be the same. Because the idea is, the only way this can be equal is if we're raising 12 to the same power in both spots. So we just set the two exponents equal to each other, and we find out x has to equal 3. Okay, 17 is similar. It says 9 to the x minus 3 equals 729. So this time our goal is to figure out what power of 9 and gives us 729. So I'll just try 9 cubed to start with. Oh man, lucky 2 times in a row. So we can rewrite 729 as 9 cubed. So it's still the same process as the last one where we want to set the two exponents equal to each other, but we will have one extra step here because it's not just x. So we'll set x minus 3 equal to 3, add 3 to both sides, and we get x equals 6. Okay, 18. We're simplifying the square root of 98. So I've got to think, let me maximize this again, sorry. So we got to think of all the things we can multiply by to get 98. So let's see, 2 and 49, 3 won't work, 4 won't work, 5 won't work, 6 will. Oh no, it won't. I was wrong. 7, 7 and 14. 8 won't, 9 won't, 10 won't, 11 won't. Okay, I think we've run out. So it's just those two. 2 times 49 and 7 times 14. The only perfect square we see is the 49. So we'll rewrite this as 49 times 2. Or if it's more helpful to you to see it separated in two square roots like this, you can write it that way. Up to you if you want to do both or not. But then we can say, we know the square root of 49, that's 7. Square root of 2 we don't know, so we'll just leave it as the square root of 2. Okay, 19. Square root of 6 times the square root of 18. Our first step is to go ahead and combine those two. So we do 6 times 18. I believe that's 108. 6 times 8 is 40, yeah. That's 108, so we got to think of what numbers, and you can use your calculator to help you with this. You could just do like 108 divided by 2 and find out, oh, okay, that's 2 and 54. You could do 108 divided by 3 and find out that's 36. Let's see, 4, and I think 27. Yeah. 5's a no-go, 6. Let's see. 18. 7 won't work. 8 won't work. 9 will. It's 9 and 12. Now I think that runs our course. So we actually have a couple, or several, 3 I think, perfect squares we've got. We've got 9, 4, and 36. Remember, when that happens, you always want to choose the bigger one. So we'll want to use this pair because it has the biggest perfect square. So I'll rewrite this as the square root of 36 times 3. The square root of 36 is 6, and we'll leave the square root of 3 on its own. Last one on this page is number 20. We have the square root of 50 x cubed y squared. So with the number, we've got, let's see, 2 and 25, 3's no go, 4 no, 5 and 10, and I think that's it. So the only perfect square we see is 25. So we think of this as the square root of 25 times 2. The square root of 25 is 5, and we'll have to leave the square root of 2 inside. So I gave them some separation in space just so we can work with the x and the y. But the point is the square root of 25 we can bring out, it's 5. Square root of 2 we don't know, so we leave it inside. When you're dealing with variables that have exponents, we're always going to be doing square roots. Square roots always cut exponents in half. So you say, all right, how many times will 2 go into 3? 2 goes into 3 one time, so 1x comes out, and has a remainder of 1, so 1x stays in. So we do 3 divided by 2, which is 1 with remainder 1. 2 will go into 2 one time, so we have y out front, and you don't have to draw these exponents unless you want to. But there's no remainder, so no y's stay inside. So another way to write our answer would just be 5xy square root of 2x. Sorry, I don't know where I got. I think I just have a typo in the book. I'm pretty sure my answer is spot on. There's no way they could, yeah, they just missed the book. Okay, that is correct. Okay, give me just a moment. We'll switch over to the other two pages. There's just a few more problems. Page 414, number 1 through 4. Okay, this is just rewriting. I'll just show you the ones in the book. So this is just rewriting expressions. So just a reminder, 1/2 is the same thing as a square root. If they had a 1/3, that'd be the same as a cube root. 1/4 is the same as a fourth root. So 1 over a number is just that root. So square root, meaning 2, root of 2. Cube root would be 1/3, and so on. So for this one, to rewrite it, we just change it from an exponent of 1/2 to a square root. Okay, now in 2, it's the same idea, but what you have to recognize is that 1/2 exponent only applies to the x. So only the x gets placed inside the square root. So the 3 stays outside the square root because it's not being raised to that power. Only the x is. Okay, 3 and 4 just going in the opposite direction. Just like an exponent of 1/2 is the same as a square root is the same as an exponent of 1/2. Now on 4, both the 8 and the n are being square rooted. So that's why we put them in parentheses to show that both of them are having the exponent applied to them. So that might help you see the difference between number 2 and number 4. When both are inside the root or the radical, they both have the exponent applied to them. When the exponent only applies to one of them, only that piece goes inside the radical. Okay, last things, page 424, 17 and 18. Let me actually write these down so you can see this page 424, number 17 and 18. Okay? So these are basic because, sorry, I'm not visible to you yet. Let's fix that. Because when these already have the same radicals, meaning the same thing as under each square root, it's very straightforward. We would just say, okay, this is 3 square root of 5s. This has 6 square root of 5s. So if we add them together, we have a total of 9 square root of 5s. So when these match, all you do is simple addition or subtraction. 3 plus 6 is 9. Okay, then 18, we have 8 square root of 3 plus 5 square root of 3. So it's another straightforward one where the square roots are the same. Both have a 3 inside, so we just add 8 plus 5 and get 13 square root of 3. Okay, do your best on this test. I know this material has been challenging, but I also guarantee that if you'll study and work through what each question means and how it works, you can get there.